everyone. Thanks for joining. My name is Craig Reuter, and I am one of the product managers with the Precision Components team here at Oerlikon Balzers in the United States. I've been with the company for 9 years as of tomorrow, and a total of 14 years in this industry, and I work from my home office in Minneapolis.
Hello, good morning, good afternoon, and welcome. My name is Adam Gorczewski. I am the head of sales for Precision Components for the Americas region. I have been with the organization for approximately 4.5 years, and I work out of my office up in Guelph, Ontario, Canada, which is about an hour west of Toronto. So thank you and nice to have you. Just wanted to give everybody some background on Oerlikon Balzers. Here is a global overview as to where we are located. I'm going to focus my efforts on the Americas region. So in Americas, we have 27 centers or service centers that are available. In those centers, it's kind of divvied up that there's 2 centers in Captain, Canada. We have about 18 centers in the United States right now, and the rest of it is actually divvied up with Argentina, Brazil, as well as Mexico. Okay, so moving on to the second topic on the agenda is a coating. Why would we actually have a need to use a thin film coating? Well, there's numerous reasons. So we've actually put a couple of topics here as to what people might think of and what these coatings actually offer. I'll go through the list very quickly here. We're obviously able to reduce friction for specific applications. We improve performance by applying coatings to different components. We're able to provide different piezoelectric properties. We have found solutions to replace the hexavalent chromium, which is being phased out right now, reducing wear on the application, which essentially what that does is actually increase the lifetime of equipment. There's also, you can look at coatings from a cosmetic aspect. So there's different colored coatings that are available. And if you look at the costing of the thin film coating in retrospect to the actual system or the application, it's a very small price to pay in the grand scheme of things. Okay, and then some of the benefits that the thin film coatings are actually able to offer. So we actually put together 4 bullet points here. First and foremost, we use the coatings as a means to reduce friction as well as to reduce wear. Okay, there's different types of wear mechanisms that system actually sees, but this is probably one of the primary reasons why you would actually go ahead and apply a coating. Second, we're going to talk about some electrical properties. So with our coatings, we are actually able to provide a coating that shows conductivity or provides conductivity, or depending on the type of coating, we can apply a coating which will actually provide us with resistivity. Okay, and looking very quickly on the chemical properties, the coating, so you'll see an image here of being hydrophobic or hydrophilic. We have the ability to influence the wettability of a product. The coatings also have very good anti-sticking properties and also offer corrosion resistance. And last but not least, the coatings which we do offer actually are able to be offered in different colors. So ultimately what that does, it provides you really nice visual aspects. But given the fact that the coatings are quite hard, they also provide a very good level of scratch resistance.
Okay, thank you, Adam, for this explanation. I mean, here, these are definitely, the bullet point that we get or the question we have most of the time. But I would like to actually start a poll because it's always good to have, the feeling of the participant today who come to the webinar. So I'm going to start a quick poll right now. So please choose the options why you may need a coating. So it could be several options: friction, wear, corrosion. If obviously none of the answer really suit you, you can go with the others, and please use the question box then to ask really what kind of properties you may look with the coating. So I'm gonna let an extra second and then I will close the poll. All right, perfect. So I'm gonna close it for now. And what we can see, okay, so a lot of people are mainly interested by the reduction of the friction and the wear. Obviously anti-sticking, okay, very interesting. And others, I would have a look then into the question box if basically I get a specific request. So we let now Craig to continue to present our solution and coatings.
All right, thank you, Mark. We're going to talk about DLC coatings and their properties and the technologies by which they're created, as well as technologies for PVD coatings. And it's not advancing for me. Mark, would you be able to do that for me? I'm not sure why. Thank you. PACVD process, known as plasma assisted chemical vapor deposition, also referred to as plasma enhanced chemical vapor deposition. There is a video to follow here shortly to give you a better description, so I'll let that do the talking. But on the right, you can see the actual glow discharge around a component as the coating is deposited onto the surface. All right, Mark, diamond-like coating, diamond-like carbon structure. The chemical structure is the graphitic structure, SP2, and the diamond structure, SP3. Combined, they give you what is called a diamond-like carbon coating. There are various DLC types. You have hydrogen-containing DLC, ACH, hydrogen-free DLC, so you have the TAC, the ACC, and doped DLCs, whether they're metal-containing or whether other components. Okay, here you see a nice cross-section of a DLC coating. You can see the amorphous structure. It's a very wide family of coatings. The main characteristics of DLC coatings, as you see here, are high hardness, which is the SP3 content, low friction, thanks to the graphitic content, in order to reduce wear. So we offer multiple solutions in order to produce DLC coatings, as you see here, the amorphous carbon with hydrogenated amorphous carbon and tetrahedral amorphous carbon. All right, Mark?
So thank you, Craig. So as Craig mentioned, sometime a video should explain very quickly and better how it works. So I'm going to put now a quick video about the PACVD process. How does it work in order for you to have a quick understanding?
Appropriate for today's topic, MILUBIA, is the PVD process. There are two common methods for evaporating target materials. One is sputtering, one is arc evaporation. And again, there's a video to discuss this as well, so I won't go into too much detail. But you are essentially metal ions and reactive gas atoms form a very hard, well-adhering coating to the surface of the tool or the component using either of these methods. The BALINIT MILUBIA falls under the PVD arc evaporation process.
Okay, thank you, Craig. So here I think it's important to mention it because a lot of people are talking, about PVD coating, but the PVD is not a coating, it's actually a process on how to apply a lot of different coating and solutions. So I'm going to launch another quick video, this time about the arc evaporation process. And you will see that even if the global structure, we are in this chamber, we have a plasma, there is a lot of differences into the process itself. Okay, so that was a quick video, and as you may have seen at the beginning of the video, you can see a lot of this electrical arc created on the surface of the target that will generate a lot of droplets on the surface. So it's true that the PVD arc coating is a very hard solution. Post polishing is very often required because of these targets. But now I will let Craig continue with the specific focus about the solution MILUBIA.
So what makes BALINIT MILUBIA a unique coating? First of all, it is a TAC, or tetrahedral amorphous carbon coating. And TACs have the highest thermal stability and hardness, and among the lowest coefficient of friction as well for tribological properties, both in boundary lubrication and water environments, which makes this coating unique. It's a corrosion-resistant coating, and it can be applied to most metallic, polymer, and ceramic substrates, so even on non-conductive substrates. You see the various examples of ceramics and polymers, or even carbon fiber reinforced polymers, other woven materials there like elastomers and metals. So it's a very wide range of substrate materials that can be used. Okay, we call it the filtered plasma accelerator process, FPA. As you can see in the diagram below, we have ion beam sources with a filtering process to eliminate the droplets that reach the workpiece. So it has a very limited impact on roughness, a very low deposition temperature, so under 100 C or under 212 Fahrenheit, and very precise control of thickness and flatness and uniformity. As we said before in the previous slide, multiple substrates that this coating can be applied to because of the nature of this process. And we can also use this technology not only to apply a TAC coating, but also metallic coatings and oxide and nitride coatings as well. So you have on the left an ion beam etching for surface cleaning. I'm sorry, Mark. Ion beam etching for surface cleaning to provide a little bit more cleaning process before the coating for better adhesion, the coating process, and then you end up with a very dense coating layer with a very good adhesion. All right, thank you. A list of some of the coating properties here. You see a nice cross section again on the left, the TAC material again, the coating process, once again, the coating temperature, thickness. Because the coating is so hard, it is limited to a thinner range of coating, 0.1 to 2 microns typically, and a coating temperature stability, which is also on the higher end of DLCs at 450 Celsius, or approximately, 842 Fahrenheit. Very low coefficient of friction and certified for food contact and drinking water contact. And here you see on the very bottom the vessel dimensions, so you can get a rough idea of what some of the component or tool sizes are that could be done. So a diameter of 600 millimeters, or about 24 inches, and a height or a length of 1050 millimeters, or 41.3 inches exactly. Okay, now the fun stuff. You can go to the next page already. A little bit about the Tribosystem, the study of two components moving against each other. You have sliding motion and you have pressure, and you have various influences of temperature and pressure and humidity, roughness of the two surfaces that are sliding against each other, and you've got various materials in the intermediate. So you've got lubricants, you've got whether it's water, particle, and contaminants that are going on in there, all which affect the performance of these two components working together. Okay, roughness, surface roughness matters considerably, especially when we're talking about extremely hard coatings like DLCs, especially in the TAC family. You've got a lot of pressure, sliding motion, and what can occur if the coated surface is too rough, as you see here in the first little diagram, is they're going to break off. The peaks are going to break off during operation, as you see in this illustration right there. That then results in exposed substrate, which then can lead to adhesive wear. So for example, that you're trying to avoid, or you get pickup of material from the uncoated body working its way into the rough surface of the coated component, leading once again to adhesive wear that then wreaks havoc on the entire Tribosystem. DLC coatings have this running in feature to them. So you can coat one surface, the coating will transfer to the mating surface, and you get a reduction in the asperities on both surfaces. So once you get past the initial run-in, then you see a steady, almost constant wear and coefficient of friction in the Tribosystem. Okay, so here we have some examples for you. This is how we test, and so the values that we publish are based on the pin on disc method. And I will say that Tribosystem, it consists of a lot of influencing parameters. So predicting wear life is difficult based on, but it's going to be based on specific trials and experience. But as I said, the values that we publish are based on pin on disc, and this gives you a guidelines for coating selection. So you can somewhat predict how they're going to behave in your particular tribology. On the right here, we have compared using this test methodology chromium nitride, which in and of itself is a very good sliding wear coating in a lot of applications, and compared it to MILUBIA. So against uncoated steel, against the oxide, against ceramic, and then running against itself. And as you might expect, running against itself, you get probably the lowest coefficient of friction entirely. All right, Mark. As we mentioned before, in water conditions, you can also get very low coefficient of friction. In this example, you can see the test parameters on the left, and the lubrication is that the samples are immersed in water. And we'll show you a couple of applications here in a second. So on the right, you can see the profile, the friction of these uncoated discs and pins. And then you can see with MILUBIA and MILUBIA with post-polishing, an even better result in coefficient of friction. Okay, so an example, mechanical seal for water pumps. In this example, you'll see that one of the chief benefits from low friction is less heat generation. So on the left, you can see the silicon carbide running against silicon carbide, a very rapid increase in temperature, whereas the silicon carbide coated with MILUBIA has a minimal increase in temperature, and it remains constant because the friction coefficient also remains constant. So you have a longer dry running time without failure, and you don't have the typical damage that you'd see on seals that reach very high temperature. So therefore you have less downtime, lower repair costs. Okay, ceramic shafts and bearings for pumps. Here again on the left, you can see the behavior on the pin on disc test of just a bare uncoated aluminum oxide as compared to coated with BALINIT MILUBIA. Minimal increase in friction as the system runs in, and they're very constant friction coefficient. So you got low friction against the aluminum ceramic, low operating forces, and improved efficiency, less scale formation because of the low surface energy or release characteristic of the coating, less noise in the system, and therefore reliable long-time operation. Next, please. So a clear example in the water is a ceramic seal disc for sanitary fittings, faucets. Distinct advantages there. Operation forces stay low, even if the assembly grease is washed out. Grease used during the assembly process is washed out. You still have very low operating forces. So it's a very, very smooth operation of the faucet handle. It reduced lime deposition, which would otherwise cause an increase in friction and wear of the cartridge, and a very good flow and temperature control. Faucets and shower heads, very smooth, very precise. All right, Mark, thanks. A completely different application in food processing world is meat grinding plates. These meat grinding plates are typically made of D2 tool steel or S7 tool steel. There are multiple diameters and thicknesses that are used in the various machines. And as a plate begins to wear and the knife inserts running against it begin to wear, then the cut quality is reduced, and therefore the cooking behavior of the meat is influenced negatively. So the benefit of having a coated solution is the holes stay sharp. The knives are uncoated, but they also have a bit of a polishing effect running against the coated surface. And so you have a continuous shearing cut rather than a squeezing or just a plain extrusion. And you get a very improved service life of the components. And one of the biggest advantages is you are no longer taking 15-20 minutes 2 or 3 times a day or 4 times a day to replace knives and plates, and therefore your throughput is significantly higher, improving the profitability of that machine. All right.
Thank you, Craig. I will talk about some other applications which we offer with the MILUBIA coatings. In this specific example, we are actually able to apply a coating to a tweeter dome in a audio speaker. And what that allows us to do is it allows us to stiffen the dome, and ultimately by stiffening the dome, we're able to allow or provide a higher resonance frequency and ultimately increase the breakup threshold at a specific frequency. What that ultimately does is it provides a much better or much clearer acoustic sound quality. What's really interesting about the application of this coating is that it's very thin and it's also very light, so it has no impact on the weight of the coated tweeter dome. And given its properties that it can be deposited at very low temperatures, we can see here in the substrate materials that we can actually apply it to aluminum, magnesium, titanium, polyester, as well as a number of different composites. Okay, the next application that I want to talk to you about is an application where we actually coated a Viton, so which is a rubber membrane, for a measuring head that is used in a paper machine, and that machine is ultimately used for quality control purposes. In this specific instance, we wanted to address the electrostatic discharge related to this application, and essentially what we were able to do is reduce this electrostatic discharge by maintaining the other functions of the membrane. Some dimensions is about the membrane had a diameter of about 2 inches and a height of approximately about 1/4 of an inch. Okay, yet another very popular application is sealing rings, which are used on suspension forks. These suspension forks can either be used in motorbikes or even bicycles, mountain bikes, I would say. Again, because of the low coating temperature properties, we are actually able to coat or deposit a coating onto these elastomer or NBR sealing rings. Ultimately, what it allows us to do is it allows us to address some of the potential sticking and wear mechanisms that are actually being seen right now. And what you will also note is that by offering a lower coefficient of friction, the amount of force that is required for the operator or the driver or the rider to move these forks up and down is actually significantly reduced compared to a sealing ring, which does not possess this type of coating. And a few additional examples that we have that we want to talk to you guys about is modification of wettability. Okay, so with the coatings, we actually can influence the wettability of a specific component. We talk about ESD, so this is the electrostatic discharge detection. You can see parts that have either been coated or not coated. Surface functionalization. So in a couple of recent examples, what we were able to do is apply a coating to a plastic where you bond two pieces of plastic, and the bond with the existing adhesive is only 1/3 as strong as it is if you were to actually pre-deposit a coating on one of the substrates. Then you apply the bond to it, and then you bond the pieces together. So we're seeing some really good results for that. And also we're working very closely on developing smart coatings relating to sensors. And with these coatings, we were actually able to allows the user to determine the temperatures, pressures, perhaps points at which the equipment has to be replaced, or if it's reaching a specific threshold where it has to go up for maintenance, etc. So that's something that's relatively new for us. But again, with this coating and the application at low temperature in the thin film, as well as a smooth surface finish, we're actually able to provide some solutions in regards to smart coating services. So, key takeaways, what we've been able to learn through this webinar is that Oerlikon Balzers has a very wide range of solutions and technologies. With these coatings, we are able to provide a very low friction coefficient, and whether that be in a dry environment or even in a lubricated environment. Post-polishing is always an option, but again, with the MILUBIA coating, because it's a filtered arc process, the as deposited surface finish is actually quite smooth. The coating, I would say, is multifunctional, and what we mean by that is because of the lower temperature deposition, we're able to apply it to different substrates. And that kind of ties into the second last bullet point, where we're actually able to provide the coating on a wide range of different material grades. And obviously with this technology, what it does for us, it opens up new doors for different types of applications that might have previously not been even looked at due to the fact that this type of technology was not previously available.
So thank you very much again. We can wish you only a good rest of day or good evening, depending where you are in the world. And we hope to talk to you very soon.
Thank you.
Thank you.
Thank you very much.